Welcome back to the Deep Dive. We're digging into, well, some really fascinating stuff today. We're heading out into space, sort of, to tackle some common ideas. Myths, really, that a lot of us still believe. It's incredible how science changes our perspective, isn't it? Makes the universe even cooler.
Oh, absolutely. And these myths, they're everywhere. Pop culture loves them, but the real science, often much stranger, much more amazing. So, yeah, let's dive into the facts.
Okay, first up, movies. Big space battles, right? We always hear these massive explosions, the whoosh of engines. So I guess the big question is, does space actually have sound? Is that real?
No, not in the way movies show it. That's all added for effect for the drama. See, space is mostly a vacuum, almost completely empty.
A vacuum, right? Meaning no air.
Exactly. Sound needs something to travel through, like air molecules vibrating. If there's basically nothing there, the sound waves just can't go anywhere.
So if, like, two astronauts are just floating out there.
And they shouted at each other.
Yeah.
They wouldn't hear a single thing. Nothing at all. It's profoundly silent out there. Now, technically, there are plasma waves in some really dense places, like near the sun or nebulas that sort of act like sound, but that's not audible noise like an explosion. It's different.
Wow, okay. So real silence. Got it. That's kind of mind-bending in itself. All right, sticking with things we think we know. Let's talk about the sun. We all see it, right? Looks yellow, maybe orange at sunset. But here's where it gets really interesting. Is the sun actually yellow?
It's a great question, and the answer is no, not really. The sun itself actually emits white light.
White, like pure white.
Yeah, a blend of all the colors in the spectrum, all of them together. The reason it looks yellow or orange to us here on Earth is because of our atmosphere.
Ah, the atmosphere is doing something.
And it is. It acts like a filter.
Yeah.
There's this process called Rayleigh scattering. Basically, the air molecules scatter the shorter wavelengths of light, the blues and violets, much more effectively. So that blue light gets scattered all over the place, which is why the sky looks blue. And what's left coming more directly to your eyes from the sun, more of the longer wavelengths.
The yellows, the oranges, the reds.
Exactly. So our atmosphere filters the sun's light. If you were in space, looking at the sun without that filter,
it would look white.
A brilliant, intense white. Yeah.
Fascinating. So our view is literally colored by where we are. Okay, let's move on to another classic sci-fi scene. The person exposed to space without a suit. They always seem to instantly freeze solid or, explode messily. So what's the reality there? How fast would things go wrong?
Right, the instant freeze or explosion, that's definitely a myth. It's dramatic, but not accurate. You wouldn't explode. Your skin is actually pretty strong, surprisingly resilient.
Really? It holds you together?
It does. Now, you would experience swelling quite significantly because of the lack of external pressure. Ebulism, it's called, but not bursting. And freezing. That's also much slower than you'd think.
Slower, but space is incredibly cold, isn't it?
It is, but heat doesn't transfer quickly in a vacuum. There's no air or water to conduct the heat away rapidly like on Earth. You lose heat mainly through thermal radiation.
Radiation, okay.
And that's a relatively slow process for a human body. It would take, potentially hours to freeze solid. The immediate dangers are actually lack of oxygen and the effects of low pressure on your bodily fluids, not instant freezing or exploding. It's grim, but different from the movies.
Hours. Wow. So it's not quick and violent. It's something else entirely. Still terrifying, obviously. Okay, last one for today. We touched on this with sound the vacuum of space. We often hear it called a perfect or complete vacuum. Is that strictly true? Is it absolutely empty?
Good point. It's an oversimplification, really. While space is incredibly, incredibly empty compared to Earth, it's not a perfect vacuum, not absolute nothingness.
So there's stuff out there, even between the stars.
Yep. There are tiny particles scattered around, mostly hydrogen atoms, just a few per cubic meter in interstellar space. Some dust, too. It's extremely sparse, not enough to breathe or carry sound, obviously.
But not zero.
Not zero. And while it seems insignificant, for spacecraft traveling at incredible speeds, even those tiny particles can matter. They can cause erosion over long missions. So, yeah, very empty, but not completely empty. It's another nuance the simple term vacuum misses.
So let's recap quickly. Space, basically silent. The sun, actually white. Exposure to space.
Yeah.
Bad, but you don't instantly freeze or explode. And space itself, not quite a perfect vacuum. Man, knowing the real facts just makes it all seem even more vast and amazing.
It really does, doesn't it? And it makes you think, what else do we have slightly wrong? What other cosmic truths are waiting out there, even more incredible than the fiction we imagine? The universe is full of surprises. It just encourages you to keep asking questions, keep looking deeper.